So these are permutations. Super fun. My least favorite unit. Yep. I was hoping Thompson would show up and teach it. This is where I just go missing in action for Monday, Tuesday. Don't look for me. Fundamental counting principle. So that just states that if, okay, do you guys remember doing probability from grade 9? Like, so what's the probability if you flip a coin that you'll get ahead? 50-50 or 1 out of 2? Okay, what's the probability I'll roll the number 3 on a dice? 1 over 6, right? 16 your total. There's only 1 3 on the dice. What's the probability that you will get an even number on a dice roll? 3 out of 6, or 1 over 2, or 50-50. Those are you with me so far? Okay, so there's lots of ways to say it. Now, here's the question. What's the probability that I will flip? I'll get head on the flip, and I will get the, and I will get 5 on a roll. 5 on a roll. It is. It is. Wow. Right? So the probability of getting ahead is 1 over 2, and the probability of rolling a 5 on a dice is 1 over 6. Now, if I want to know what the probability is of those two things happening at the same time, what do I do to those mathematically? Multiply the fractions. So I'm going to have 1/2 times 1/6 gives me 1/12. Does that make sense to everybody? Easy peasy. So that would mean that there is 12 possible combinations in flipping a coin and rolling a dice. Right? That makes sense? What would they be? We could get a 1 and a head, a 2 and a head, a 3 and a head, a 4 and a head, a 5 and a head, and a 6 and a head. What else can I get? 1 in the tail, 2 in the tail, 3 in the tail, 4 in the tail, 5 in the tail, and 6 in the tail. How many are there? 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 possibilities. Now, permutations, I don't know. I'm going to stop talking. I'm going to keep doing that. All right. So the total ways in which this can occur is what? What did we do? What did we do? So the total possibilities on a roll of the dice is 6. The total possibilities on flipping ahead is 2. What do we do to get 12? We multiply them. So we would take the first event and multiply it by the second event. Now, what do we mean about independent events? Right. Neither. So if I flip a coin and I get head, the next time I flip that same coin, do my probabilities change? No. A dependent event would be like if I have a bag of marbles and there was 3 blue marbles and 2 red marbles, and you picked a marble out and didn't put it back in the bag. That would affect the next event. Does that make sense, everybody? So this is what your probability in grade 9 is leading to. Some people are never going to make it here. Yeah, I mean, probability and then grade 1. I hate it. Now, I feel like we could do some of it. I feel that maybe not all of it. Okay, how many different license plates are possible in the province of Manitoba? Okay, what about 6? So on our license plate, we have 6 different things. So there's something special about the things. Okay, so 3 are letters. And we're going to ignore vanity plates. Okay, for us mere mortals who can't afford stuff like that. And the last 3 are numbers. Question about license plates. Questions about license plates. Can you repeat letters or numbers on a license plate? Yes, you can. Yes, you can. Game over. Done. So what we're looking at is we are looking at how many possible choices do I have for the first letter? 26. Because I can pick any letter in the alphabet, right? Next letter we said we can repeat, so it's an independent event. So 26 again. The third event is going to be 26 again, because I can repeat the letter. My dad's license plate that I can remember was BBB040. His name's Barry. It worked out beautifully. I know. What about numbers? And gotta count 0. BBB 040. You can definitely use 0. So we have 10, 10, and 10. What is it that I do with all these numbers to figure out how many possible social combinations? Multiply. So if you do that in your handy dandy calculator, you should get 17,576,000 possible license plates that can be produced.
What happens if we have
well, Ontario, I think, got into that situation. They had to add another letter. Because I don't know if they put, like, so if, let's say, I run off my car tomorrow and I don't buy another one, what happens to my license plate? Does it go back in? Does it get, because my last car that I sold, I got new license plates for the new car. I don't know why. I just decided that's what I want to do. This one I wanted to change. So what happened to my old license plate? I don't know. Maybe we need to call FBI. I'm not sure. I know. These are questions I can answer. I honestly don't have an answer for you. All right. So how would the question change if neither letters nor numbers could repeat? So now my first number would be 26 because I have access to all letters of the alphabet. My second one, if they can't repeat, whatever letter I picked the first time, let's say I picked K, that means that's not available to me anymore in the second pick. So this would go down to 25. This would be 24. Going back to the numbers, my first number, I have all 10 digits to pick from. Then I only have 9 digits and then 8 digits. And again, I'm multiplying all of these. And that's going to equal 11,232,000. I still love license plates, but I don't know what happened when I had PP 451. I don't know where that went. Maybe somebody's riding around with it. Who knows? Really? Like you could look up my license plate, like if you saw my license plate, like if I ran a stoplight, I don't think you can. I think only RCMP can run it. Yeah? Okay, I don't want to get drafted. I'm not telling you. You know my old one, look up what that one's doing. All right, so what is the question? How many ways can a teacher sit 4 girls, 3 boys in a row of 7 if boys must be seated at each end of the row? This is why they permutate.
What is the flanker?
Okay, so I got 7 seats. So I got a restriction on it. Order matters in this. So tell you something very specific. Boys have to see where? At the end of each row. So this has to be a boy, and this has to be a boy. So let's deal with our restriction first. How many boys could possibly sit in seat 1? 3. How many boys could possibly sit in seat, or the last seat? 2. You can't be the boy sitting in seat 1 and take up seat 2. Can't do that. Can't put a butt cheek in either seat. Doesn't work that way. So 2 seats have been taken out. How many seats do I have left? 5. Does it say anything about the order? Does it matter where that third boy sits, or it's got to be girl, boy, and rest girls? It says nothing about that. So what I have left is 5 people. Doesn't matter your gender, just where they sit doesn't really matter. So this is going to be 5, 4, 3, 2, 1. So these seats make up so those middle seats have no gender requirements on them. It was the boy on either end of the row. I don't know why there's going to be a question about a math textbook on either end of the shelf. Yeah. Yes. Oh yes. Yeah. It's the chapter nobody likes. I would treat identities till the cows come home before I do this. So anytime you've been given a restriction, deal with your restrictions first. Okay? Okay. Oh, how much would this give me? 720. Good thing you've got your notes. I've got my notes for all of you. Did you? What? Pardon? Nice Michigan results. Maybe it's only the American site you can look it up. Maybe my prayers I don't know. Hopefully it's not under my name. So when we deal with factorials, those would be exclamation points. There is an exclamation point button on your calculator. And yes, in English they mean we're excited or we're trying to make an emphasis or a point. I'm kind of excited about them, but not. But I would like to, but I'm not. So if I do 4 exclamation point, what that means mathematically is 4 factorial. And what that means is 4 times 3 times 2 times 1. So instead of writing all that out, it's all the positive integers leading up to the number. So if I do that math, 4 times 3 is 12, 12 times 2 is 24, so it's going to equal 24. 8 factorial? What would that be? 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 equals 40,320. I feel like maybe we should try this in our calculators. Huh? Nope. 1. I'd like to say it has to do, it does start, but all of our factorials end at 1, and I'm wondering if that's the reason. I don't have a good answer for you guys. I will look into it. I will ask my sources. Okay, this you need to know. This is where we expand it to algebra, and everybody hates this. It's not that hard. So you start with the number. How do you get to the next number? And how do you get to the next number after that? How do you get to the next number after that? Right. You guys with me? Okay. We good? We just keep going down to one. But when I give you a question with consecutive numbers, you guys hate those. They're not. Because you're just adding one to get to the next consecutive number. So if I start at k plus 1, that's my first number. What do I do to get to the next number? You guys just told me. What do I do?
K plus 1 minus.
Right, k plus 1 minus 1. So that would just be k. What's next? What comes next? What comes next? And we can say that this goes on forever. You guys know how to use ellipses in math, right? How many dots? 3. Eucalyptus. Pardon? No, it's ellipse. He called it eucalyptus. I'm going to roll with it. Okay, we got our last unit. If you want to call it eucalyptus, you can. Yeah? Okay. Sure. Okay. So that makes sense though. If you have nothing to organize, you can only organize nothing one way. There's nothing to move around. This would eventually get to, what do all these ones eventually go to? So what would this one eventually get to? Does that make sense? So in general, n factorial, the n minus 1, n minus 2, n minus 3, when n is greater than 1. Greater than or equal to 1, sorry. Okay, so we're going to do some simplifying of factorials. And this is going to help you with the formulas in this unit. So if I want to simplify this, you can do it a couple ways, but I'm going to show you the easy way to do it. So I'll show you the long way first, and then I'll show you the easy way. So the long way would be 5, expand it completely, and then expand the denominator completely. Well, you may not have a calculator. So. Okay, so what would we do here? I wouldn't multiply them all out. I just start canceling out factors, and I'm left with 5, not 5 factorial, because I've expanded my factorial. There is an easier way to do it. Oh my goodness. Brilliant. Surround myself with geniuses. It's bound to rub off on me someday. So instead of wasting your time expanding it completely, not that big of a deal for 5/4, but all of a sudden it's getting to be a bigger deal when I'm dealing with 16 or I'm dealing with 200 or something like that. You can just expand it to, because really this, what's this? That's 4 factorial. So my answer is 5. So what would I do here? Where would I expand my 16 to? To 12, because I want to get rid of that. So 16 times 15 times 14, I really need to leave myself in the room. 12 factorial will stop there. Why? So I can cancel it out. So that 12 factorial cancels out that. I'm going to expand my 3 factorial. I'm going to expand my 3 factorial to 3 times 2 times 1. I'm going to do some fancy math here. I'm not going to multiply and then divide it. I'm going to get it smaller. I know that 3 goes into 15 how many times? So cancel the 3, change the 15 to a 5. 2 goes into 14 how many times? 7. 1 goes into 13 times, so I'm not going to have to do that. So really what I'm going to be multiplying is 16 by 5 by 7 by 13. I have no denominator, and so that's going to be 7,280. Now that's a pretty big one. That didn't help simplify, but by doing this, when you get into smaller numbers, you're going to be able to do this without a calculator. Is my hope. Okay. I am like big writer is what it was. No, that's new for me. Okay, this one. What am I expanding the top to? So I'm going to go n minus 1, n minus 2. I'm going to stop there because that's 2 factorial. And this is n minus 2 factorial on the bottom. Those will cancel each other out. And I'm left with n squared minus n. Easy peasy, right? I'm just going to go up. Okay, so going up, my numerator, what am I going to expand that to? 7 times what? 6 factorial, because that's going to get rid of the one on the denominator. R plus 1, R minus 1 factorial, all over 6 factorial, R minus 1 factorial. So I'm left with 7R squared plus 7R. Woo! Easy. Easy. Are you going to skip this one too? No? I think you're lying. Okay. We'll wait. Do you guys want to like that? On the next Thursday, it's going to be here? You think they'll be here? All right. How many different orders can someone play 4 CDs? What? A few. 24 ways. Because if we play 4 CDs, my first option is going to be I have 4 CDs to play first. And then once I play that CD, it's gone. And now I've got 3, 2, 1. You can. We're not going to count that. You could write it either way. I'm fine with either answer. For me, who struggles with this unit, this makes more sense to me to have my little dashes and put them on. Some of you who are more skilled and proficient at this, 4 factorial makes more sense. All right. So essentially, there's a formula to work for permutations. It is on your formula sheet. Okay? No need to get a tattoo. You will get this formula. So N and R. N and R. What? So, okay. Used to represent permutations or arrangements in a definite order. Are items taken from a set of n distinct items. So which one's all of them, and which one's the part? N is all of them, and R is just a part of them. Does that make sense, everybody? No, perfect, awesome. So this is your formula: n factorial over n minus r factorial. So if I'm going to do this, I need to know that the first one, think of it, it comes in alphabetical order. N, R. Okay, it comes in alphabetical order. So I would put these in the formula. So it's going to be the permutation of 9 and 4, 9 permutation 4 is going to be equal to 9 factorial over 9 minus 4 factorial. You're not done. Simplify it now. What did you get? 3,024, yes. So for the rest of us variables as we go along, we're going to do that again. We're going to expand. So I'm going to have 9 times 8 times 7 times 6 times 5 factorial all over 5 factorial. Those will cancel each other out. When I multiply those through, Canal, who didn't show up for my test, says it's 3,024, which I would agree with. So, sorry, I was going to say you guys do this on the random. You got it. Is that what you got? What can you do about 30? Well, it's saying the permutation is equal to 30, but it's not telling me what my whole number is, like what my total number of items are. Okay? So it's not telling me that, but I can use my formula. So it's saying the permutation is equal to this. So I'm going to have n factorial over n minus 2 factorial, and that's going to equal 30. The permutation equals 30. So what do you do? Expand the numerator. n minus 1, n minus 2 factorial. Your whole goal is to eliminate that denominator. You got it, you think? Okay. What do I do here? Factor. I've got some problems. I can't have 2 values. How come? I always do. How come? Well, what did n represent? What did n represent? The total number of things in the set. Exactly. Your n cannot be smaller than your r. N must be greater than your r value. I'm saying this out loud. So I would reject the negative. Because how could you have a negative, like, so please, can you show me what it looks like to hold -2 apples in your hand? But they wouldn't be in your hand anymore. So this is the problem. I can't have a negative set to something. Okay? And if we go back up there, there was this restriction that I didn't even talk about on the formula. N is an element of the capital N. Not integers. What's natural numbers? What's the difference between natural numbers and whole numbers? They're all whole positive. 0. Which one has 0 in it, Matthew? No. The other one. Because again, can you show me what it looks like to hold 0 apples in your hand? Just like that. But how many other apples do you have? Okay, 0 is not included because you can't pick from 0. Okay. Sometimes people will say 9 pick 4. 9 pick 4. And then when we get to combinations, we would say 9 choose 4. So 9, pick 4. This reminds you that this is your whole number. I have 9, pick 4 of those. I can't have 0 here and then pick 4 of them. It just doesn't work. Oh, we just did this. I'm going to skip this. Explain why 3 can't pick 8 does not make sense. Right, because you can't pick 8 from 3 things. If I said, hey guys, I brought everybody cupcakes today, and I brought 5 of them. You do not. He doesn't get one? Okay. As long as we're all on that same page. So you can't pick more than what you have. Make sense to everybody? Do you want me to read? What's that? Okay, you guys okay with that? Make sense? Yes? I don't want to do it, but we can. I just don't think it's essential to do that one. We can skip it? Really?
I'm so confused.
It might show up on the exam. Do you want to do it? Okay. I'm going to turn to the left-hand side. I'm just going to show you like a one-sided group on this one. I'm not, like I can write it in a T-chart, I just don't think I'm going to have enough room. So let's look at the left-hand side. The way I would attack this is I would start expanding. So 100, what's my next number? 100 times 99. And we'll leave it as a 99 factorial. Oops, I got my bracket. Ooh, look at that. So what am I going to common factor out there, Garrison? 99 factorial. So if I take out a 99 factorial, what am I left with? 100. And then what's coming out of this one? Would you ever thought to do that? No. I don't think I would either, not gonna lie. That was a question on the exam after I was been like, and this would be a perfect non-calculator question. And we all would have tried a little bit, and we would have just said, I'm giving the 2 marks on this. Yeah, that's okay. I just sort of went like,
I'm going to try to figure out
without a calculator. Because that's a good, complicated, looks like you need a calculator to solve it. All right. Permutations with repetitions in it. Is it?
Yeah.
Can we go back and do more chapters there? A set of n objects with A of one kind that are identical, B of the second kind that are identical, and C of the third kind that are identical, and so on, can be arranged in this format in different ways. So all it's saying is when you have a situation where there's repetition. So if we look at the word, pool, what's repeated? 2 is repeated, yeah. The O's are repeated. Okay, so if I wanted to know how many ways I could arrange the letters in pool, not to make words, but to make word letter arrangements, what I would do So what's my, normally, what would this be for an answer? So how many ways could I arrange the letters from pool? 24 ways, right? How did you get that, Carson? We did 4 factorial, right? 4, 3, 2, 1. Everybody good with that? Okay, so that's 4 factorial. But when it has a repeat, you have to divide it by how many things that are repeated. 2 factorial. So let's start with banana for a minute. Okay. How do you? How many ways could I arrange those letters? I have 1, 2, 3, 4, 5, 6, so that would be 6 factorial, but I've got some repeats happening here. What repeats? So, hold on, how many A's do I have? 1, 2, 3, so divided by 3 factorial, and what else do I have repeating? How many N's and how many N's do I have? Matthew, what do I do with that 1B? I could do 1 factorial. But it's kind of redundant, right? You can do this where you go 1 factorial to represent the B, but you really don't need to because 1 factorial is 1. So you don't have to do that. So as you can see, so if you have a repeat, you have to list the repeats, like divide by the repeats how many there are. Okay, so same sort of thing as banana. How many different 5-digit numbers can be arranged by these letters? Or these numbers. 5 factorial over 2 factorial, 2 factorial. Now we got to finish it. So I'm going to have 5 times 4 times 3 times 2 times 1. How come I didn't just leave that at 2 factorial? I would do this. I would do that. 5 times 2 is 10. 10 times 3 is 12. So that would be a really good non-calculator question. That's something that is expected that you can multiply 3 times 10. I hope. I really hate this question. I really hate this unit. A lot, but no one's going to ask me why. Can we skip it and come back to it if we have time?
Yes.
Thanks. Okay, you lost your say. Lost your privileges. Okay, permutations with constraints or restrictions on them. Okay, so 5 people, A, B, C, D, E, are seated on the bench. How many ways can they be rearranged if E has to sit in the middle? So I like doing the dashes at this point. This makes me feel better about life. Who has to sit in the middle? I love you guys. How many E's do I have or W's, David? I just have 1. I only have 1 E. Like if David has to sit in the middle, I only have 1 David in his class. Does it matter about the other 4 people's arrangements? No. So how many people do I have left to arrange? 4. So it would go 4, 3, 2, and 1. Easy. What's that? 24. And you guys need to put units of measure on it, like 24 ways.
Yeah.
Yeah. Okay, so this is another fun one. I hate permutations. A and B must be seated together. So really, what happens now is normally I have 5 seats, right? And now I really only have 4, because guess what? A and B are set now. I treat them as one person. So if Lala and Amy are my set, I'm going to treat them as one person because I can't ever separate them. But they could sit Lala Amy or Amy Lala. So because there's 2 of them in here, they get arranged 2 factorial ways. Does that make sense? Because you can be Lala Amy or Amy Lala. Could my set sit anywhere in the 4 seats? Yes. So, Amy Lala, that matching pair, they get arranged 2 factorial ways. So that would be AB or BA. That's what that represents. And this pair can sit in 4 factorial places because they're a set now. 1, 2, 3, 4. So it's not 5 factorial ways because we're now treating Amy and Lala as one unit. Did I mention I hate this stuff? Yeah, Jerome, I feel your pain. Okay, A and B cannot be seated together. Now Amy and Lala are in a fight, and they cannot be seated together. The easiest way to do this, and this shows up on a test, and it shows up on your exam. I guarantee this question will show up somewhere. A and B can't be seated together. The best way to do it is do the total, like no restrictions. No restrictions, and you're going to subtract, which we just calculated here. The ways that they sit together, the ways when they have to sit together. So what would be the total with no restrictions? Anybody can sit wherever they want. What was that? I heard it. 5 factorial. Because you can sit in any seat that you want. You have 5 people, you can sit in 5 different chairs. So this would be 5 factorial. And I would subtract from it, how many ways can Amy and Lala sit together? 48. Does that make sense? Because we figured that out from this question. So what's 5 factorial? Sure? So 48, 120 minus 48. All right. I make it out to be pretty terrible. I feel like it is pretty terrible. Some of them suck, but some of them aren't terrible. Okay. So this one, we're going to do permutations with cases. There's just too many restrictions to get it all done in one equation. So we're going to break it up into other ones. So it says, how many numbers can you make less than 1,000 if repetitions of the digits are not allowed? So what is numbers? Give me the first number that is less than 1,000. Okay. How many digits is that? So in case 1, I'm going to do 3-digit numbers. Okay. So 1, 2, 3. Pretty easy, right? So we've done this. It says no repetitions. So what can be as my first number? How many digits do I have to access from? How come 9? Can't count 0 because if 0 is here, what does this make this? A 2. Are you okay, Kevin? You like are pained by this? Oh, okay. Just woke up. Sorry. So then so I can't have 0. So I'm going to write a restriction. Not 0. Because if it was 0 here, this would be a 2-digit number. So I have 9. Second place value, how many choices do I have? 9, because I can't repeat. Normally it would be 10, but it's taken a number here. If repetitions were allowed, it would be 10. But because repetitions are not allowed, I've picked, let's say, number 3. Like I picked my first digits. So it would be 10 minus the 1 I picked here. So this would be 9. What about the third place? 8. And what do I do with all those? Multiply them. And my handy dandy calculator says 648. So what do you think case 2 is? 2-digit numbers. I'm going to put a restriction on the first number. What is that going to be? Not 0. Because if it was 0, then it'd be a 1-digit number, and that's not where I want to be. So what's happening here? 9. What's happening here? 9. And anybody want to guess what's happening in case 3? 1-digit numbers. So, should we put a restriction? Okay, does 0 count as a number? That is the question you have to ask yourself. How many numbers can you make less than 1,000? 0 technically would be less than 1,000. Okay, what was the restriction on permutations? What was the restriction on permutations? Natural numbers. Can I pick an apple from Matthew's group of no apples? No, so we can't include 0. So we're dealing in natural numbers. So when you have cases, you add the cases together. So that's going to be 738 possible numbers. You knew it? Awesome. Okay, how many different 3-digit even natural numbers greater than 300 can you make using the digits 1, 2, 3, 4, 5, and 6? No repetitions are allowed. Welcome to my world. What was your question, Molly? Whether you're going to need this in life? Okay, so anytime you're trying to figure out how many possible things that you can make is this stuff. When you're a locker, a lock manufacturer, when I'm ordering locks from your future company for our lockers in the hallway, you need to know how many possible combinations, how many can you make, and so you have to start adding that 4th combination, right? That's you. That's what you're going to be doing. Okay, so here's the thing. 3 digits. So all my cases are going to be 3 digits. But then it says even. 3-digit even. Case number 1. So I only have these 6 numbers. So what can it end in to be even? 2, 4, and 6. So how many cases do I have? 3. So this one's going to end in 2. So 1, 2, 3. I know that this has to be the number 2. So how many number twos do I have? Only one. Okay, how many numbers are left over?
Oh,
Okay, try again.
Five.
Five. So we would just throw five in here and we're good to go. There's another restriction. Greater than 300.
Oh my.
Greater than 300. So, can 3 go here? Can 3 go here? Yes. Because I'm ending in 2, 302 is greater than 300, right? So this has to be 3 or 4, 5 or 6. Right? Okay, so how many numbers is that? 4. Do I care what the middle number is? It's the only one that doesn't have a restriction on it. Not really. So how many numbers could go here? How many have I used? 2. So how many are left? Wow. So case number 2, what am I going to end in? 4. So number 4 here. So this is going to be, I've only got one number 4. And so when I go to the front now, what comes off this list? 4. So now I can have a 3, a 5, or a 6. Because you already used 4 back here. So this would be 3. How many can I choose from here? How many are left? How many, I've picked 2 numbers. How many are left? 4. Now you understand my absolute hate for this unit. Case number 3, I'm going to end in 6. So there's only one 6. What happens here? I can use a 3, I can use a 4, and I can use a 5. I just can't use a 6. So 3 here. So I've picked 2 numbers. How many do I have left over? 4. You know, I laugh because I'm in the same boat. Like, it's just not something that comes intuitive to me.
How come it's not, how come you can't use 1 or 2?
Because the question says the number of the 3-digit number has to be greater than 300.
Yeah.
Right? So I can't, if I put a 1 here, that's a 100 number. That's not greater than 300. There was all kinds of restrictions on this question. 3 digits, even, and greater than 300. So you had a ton of restrictions on this one. So what do I got? I got 12, 12, and 16.